Hello, hello, hello. This is Coach Ikram, and welcome to this video on acids and bases. In this video, we're going to discuss the properties and nomenclature of both acids and bases. To start off, we're going to actually piggyback on a concept that we talked about in solutions, and that is the concept of molarity, which was our concentration of our solution and expressed in moles per liter. In the acid and base unit, we're going to actually use brackets to mean concentration. So for example, if you have brackets around H plus and have that equal to 1 molar, that actually means the concentration of the hydrogen ions is 1 molar. And this is just going to be a logistical way of us representing concentration, particularly where acids and bases are concerned. So we're going to start by really talking about the properties of acids individually. So an acid is going to be a compound that produces H plus ions when dissolved in water. And if you look at that drawing on the top right-hand corner, we've got hydrochloric acid dissolved in water, and you'll note that we've got H plus ions and Cl chloride ions in the water. The water molecules themselves are implied. They're not directly shown in this drawing. If you look at the bottom left, this is a less simplistic version of what's actually happening here. So you don't just have those hydrogen plus ions floating around in the water. In reality, they're going to react with the H2O molecules of the water, and they're going to produce H3O plus, which is hydronium. And that's one of the polyatomic ions that you learned earlier in the year. Some examples of acid that you're going to come across is vinegar, which is acetic acid, lemon juice, citric acid, sour candy, malic acid, and milk, lactic acid. So some properties of acids: they have a sour taste. They react with metals to form hydrogen gas. So you see here we've got a single displacement reaction of zinc reacting with hydrochloric acid. It's going to form zinc chloride and hydrogen gas right here. Keep in mind that not all metals are going to react with the acids because of the activity series. So that's just something to keep in mind when you're determining whether or not the reaction is going to actually occur. Acids are going to turn blue litmus paper red. So you see here we've got blue litmus paper. We're going to put it into what is clearly an acidic solution because the litmus paper turns red. Aqueous solutions of acids are electrolytes, and acids are going to react with bases to form a salt and water. So in this equation down here, we've got a neutralization reaction with our base reacting with our acid to form a salt and water. We're going to talk a little bit about naming acids. This is just a refresher slide. If you are still confused about how to name acids, it's important that you go back and watch the nomenclature videos on nomenclature of acids to get a more specific and in-depth review of this concept. When we're naming binary acids, that's an H bonded to one nonmetal, so for example, HF, we're going to begin with hydro and then use the root of the anion name and add the suffix -ic. So for example, HBr, clearly a binary acid, going to be hydrobromic acid. When we're talking about ternary acids, that's going to be a hydrogen bonded to a polyatomic ion. This is also known as an oxo acid and an oxy acid for your reference. We're going to begin with the polyatomic ion without the suffix, and then you're going to add the suffix -ic if that ion ended in -ate, and -ous if it ended in -ite. So HNO3 started as hydrogen nitrate, and so that becomes nitric acid. And HClO2 was chlorite, so that becomes chlorous acid. Just some side notes about naming acids. When your acid anion contains sulfur or phosphorus, the roots are going to be sulfur and phosphor. You're going to keep that extra syllable in there, not sulf and phosp. So H2SO4 will be sulfuric acid, not sulfic acid. And H3PO4 is going to be phosphoric acid, not phosphic acid. When we're talking about the strength of acids, strong acids are going to completely ionize or dissociate in water. That means all of the acid is going to break into ions. So when we say the phrase dissociate, to dissociate is to form ions. That's what's actually happening here. So if you look up on the top right, I've got a drawing here. We've got HCl. It's dissociating in water, and you'll notice that all of the HCl has dissociated into the ions hydronium and chloride. So all of it is dissociated, therefore it's a strong acid. If you're talking about a weak acid, they're going to not ionize completely in solution. Some of that acid is going to stay intact instead of ionizing. So you notice over here, we've got on the right, we have a weak acid. So when it dissolves in water, some of it dissociates, but some of it stays together and stays intact as the original acid. And so that's going to be the sign of a weak acid. There are 3 strong binary acids that you need to know, and they're listed right here. Any other binary acid, for example, any of these, is going to be weak. There are 4 strong ternary acids that you need to know, and they're listed right here, and all other ternary acids are going to be weak. So the easiest way to memorize acids and which ones are strong and which ones are weak is to memorize the strong ones because it's a smaller list. And it's going to be these 7. So make sure you know your strong 7 acids. So if you see them, you recognize them as an acid that's going to completely ionize in water. Now we're going to talk about bases. Bases are compounds that produce OH or hydroxide ions when dissolved in water. So for example, milk of magnesia is going to be magnesium hydroxide. Drain cleaner is going to be sodium hydroxide, and window cleaner is going to be ammonia, or NH3. And if you look over here on the right, we've got a drawing of NaOH, sodium hydroxide. It's dissolving in water, so you get your sodium ions and your hydroxide ions. As a note about ammonia, you notice it doesn't follow the pattern of having OH in the compound, but NH3 in water will actually make ammonium, NH4+, and OH negative. Therefore, it still follows the rule that a compound that produces OH is a base. Some properties of bases. Bases have a bitter taste. They feel slippery to the touch. They turn red litmus paper blue. So here we have some red litmus paper. I'm putting into what is a basic solution because we have it turning blue right here. Aqueous solutions of bases are electrolytes, and they're going to react with acids to form salt and water. So we've got our base right here. It's reacting with an acid, and it's going to form our salt and our water, and this is neutralization. When we're naming bases, again, this is a refresher slide, so if you need more information, go back to the nomenclature unit. But we're going to use the same rules as for polyatomic ions. So, first we've got NH3, which is known formally as ammonia. NaOH is going to be sodium hydroxide. You name your cation, then you name your anion. CaOH2, calcium hydroxide. Potassium hydroxide. And magnesium hydroxide. And all of them, naming the cation, then naming the anion. The only different one would be ammonia, which is NH3. We're talking about base strength. Similar concept to what we talked about with acids. Strong bases will completely ionize in water. All bases are going to break into ions. All hydroxides with groups 1 and 2 metals, except beryllium, are going to be strong bases. So we've got them listed right there. We've got group 1 and we have group 2. It's important to note that some of those bases are only slightly soluble or completely insoluble in water, but what does dissolve in the water is going to ionize completely, and that's what's important. Whatever dissolves has to ionize completely, and that's what makes it a strong base. Weak bases are going to ionize only slightly, so some of the base will stay intact instead of ionizing. Any base not listed above as strong is going to be a weak base. This concludes our video 1 on acids and bases. It talks about properties and nomenclature. Hopefully you've taken high quality notes, rewatch as needed, and come to class with any questions. Thanks.